Afternoon, students. I'm here today with lesson 56 for your entertainment and enjoyment. The first part of this lesson, the first two parts technically, is super fun and super easy. I learned it in like second grade. I think you're going to be happy with it. It's about set notation. And the first topic is finite and infinite sets. A set is just a group of numbers that for any reason someone has decided to create. So for example, here's an example. I said that twice. Here's an example of a finite set. Because there are just 5 members in the set, these little thingies show the beginning and the end of the set. We put commas between the different elements or members of the set, and it's finite. It doesn't go on forever. However, I could create a different set. And I could indicate that it goes on in the same pattern by going ... right? You would know, okay, 13, 15, 17, 18, oh, 21, 23, 25. You would know that, and I don't have to write it out, and that's called an infinite set. Okay, so ... is the secret. That's really easy, right? Now let's talk about membership in a set. A member of a set, so for example, 8 is a member of this set. Another word that means the same thing is an element. 8 is an element of that set. When I was learning this in grade school, we always used the word element. Now, the tendency, the fashion, you might say, is a little bit more toward using the word member. I tend to say this a lot, but member is fine as well. Okay, so here's an example. Buckle your seatbelt. It's super hard. Okay, represent the following numbers as being members of the set K. And then John gives us a list of numbers. I will write them down. 1, 0, 2, 1, 0, 5, 7, 4, 5, 7. Okay, this is the way they're presented in the book. That doesn't mean anything. 1, 0, 2, 1, 0, 5, 7, 4, 5, 7. Okay, so this is set K. And they want us to write it with the proper notation. So here's the way we do it. We write K equals, and then we make the little beginning of the set thing. Now, I like my sets to be organized from least to greatest. I don't like just random numbers. I like to organize them. We see that this is a finite set. That's cool. And when I see the smallest item is 0. Now, there are 2 zeros. We don't have to write 0 twice. Once we say that 0 is an element of set K, we don't have to say how many times. Ditto for the 1. There's a 2. Now there isn't a 3. It skips up to 4. And then we have a 5. No need to write it twice. No 6. And then we have a 7. And that is the end of set K. 0, 1, 2, 4, 5, 7. This is the right answer. Okay? This is not rocket science, you guys. You can do this. I know you know you can do it. Okay? Example 56.2. Here are the numbers. 7. That's random, right? 7, 15, 0, 1, 15, 0, 8, negative 13, 42. I miss having my students with me to help me correct my errors. It's quite nerve-wracking to know that no one's going to see if I do something wrong. It would always pop out in the end, though. Okay, so this is set L. So we use our notation again. Now, John just writes them all higgledy-piggledy messed up. I cannot do that, you guys. I cannot bring myself. So, negative number first. Then 0. There's 2 of them. And the 1. Let's see what's next. The 7. A pair of 15s. Only have to write it once. Oh, I forgot the 8. Let's squish the 8 in right there. And then 42. Okay? Again, they don't have to be in order. That's not a requirement of a set, but for my money, it is a quality of a well-organized set. John wrote it out the other way, so he's got 7, 15, 0, 1, 8, -13, 42. Okay, so the little check marks were making sure that John had them in his set. This is the right answer. All right, now we're going to get a little bit more in depth. 56.3. Given the sets, I'll write them down here. You wouldn't have to do this in your homework. A is 0, 1, 3, 5, and B is 0, 4, 6, 7, and C is 1, 2, 3, 5, 7. Okay, John asks us some questions. He says, tell us if these are true or false. And then he does A, and he says, wait, what is this? What is this? What is this? Okay, this means is an element or member of, and then if you make the same symbol, kind of like a euro sign, isn't it? And you draw a wonky through it, is not an element of. So that's what those symbols mean. Okay, so is 5 an element of A? Yes, so that's true. B. 4 is an element of C. These are true or false. So we look at C and we look for 4. No, that's not true, it's false. Okay, and then C. 5 is an element, oh no, 5 is not an element of B. Okay, we look at B, there's no 5, but that's what we're saying, so that's true. Make sense? Kind of weird. True and false questions are always weird to me because you have to like listen for the double negatives. Okay, remember this little symbol means is a member of or is an element of. I like to think of it as an element of because it looks like a little E to me, and that helps me remember. But either way. Okay, 56.4. How do you like this lesson so far? So fun, right? We have more sets. L is 0, 1, 2, 3. M is 5, 6, 7. Can you hear Gracie snoring? She rolled over and went like, she's on the floor under the table. Okay, I hope you can see that. This marker soaks through the page a little bit. So L is 0, 1, 2, 3. M is 5, 6, 7. And N is 0 and 1. Those are the elements or members of those sets. So now we have more true or falsies. A, 6 is an element of L. 0, 1, 2, 3. I don't think so. False. And B, 0 is an element of N. N, 0, and 1. Yeah, I believe that. And those are the right answers. Okay? Oh my gosh. Don't these feel good in your head? They're just so straightforward and simple. Alright, well enough of that fun. We're going to switch to topic C, which is going back to the graphing that we talked about on our Cartesian coordinate systems that were developed back in the day when philosophers were mathematicians and vice versa. And we're with a slight complication. So this is part C. It's called rearranging before graphing. All right, so we have an example. Example 56.5. Just one example? No, two examples. Graph 3x plus 2y equals 4. Well, hold up a minute, John. This is a mess. That is not the format we want. We want y equals mx plus b. This is the format we love. Whenever we're graphing lines, we gotta have this format or we're not happy. So that just means we have to do a little algebra work here to clean that up. So the first thing I'm gonna do is subtract the 3x, move that over to the right side by 2y equals 3x plus 4. And then this needs to be a y by itself. So I divide everything by 2. And now I get y equals 3 halves x plus 2. Now, I'm sorry, but we have to make a chart. I'll make it down here. And remember, I make my charts slightly differently than John, because I like to leave room to work. So I turn here are our x values, and then in order to create y, we're taking 3 halves x plus 2, and then that will lead us to our y values. I want workspace in here. Now, because we have a fraction for our slope, I'm going to choose my x values super carefully because I don't want fractions in my calculations. So, the first one I'm going to choose is an x value of 0, because I know that when I multiply this by 0, it's going to become 0. So this will be 3 halves times 0 plus 2. Well, 3 halves times 0 goes away. That just becomes 0, and so y is equal to 2. Oh, I like it so much. Now, I'm going to choose this 2. I'm going to choose a 2 because I know, look what's going to happen. 3 halves times 2 over 1, I'll write it as. These 2's are going to cancel. These 2's are going to cancel. 3 over 1 is equal to just plain 3. 3 plus 2 equals 5. I do not want to choose 1, for example, because if I multiply x times 1, I would end up with 3 halves plus 2. I don't want a fraction for a y, so I'm choosing very carefully. Because the 2 worked out so well, this time I'm going to choose a negative 2. 3 halves times negative 2 over 1 plus 2. These cancel in number, but I'm going to get negative 3 plus 2 equals negative 1. Make sense? So this fraction, the denominator in that fraction, helped me choose some really good values so that I wouldn't have a disgusting fractional point to graph, because nobody wants that. All right. Let's see, it looks like I've got to go to 5, 2, 3, 4, 5. I only draw as many hashes. All right, so my first point is 0, 2. 0, 2. My second point is 2, 5. 2, 1, 2, 3, 4, 5. And my third point is minus 2, minus 1. Remember, we always choose 3 points because even though 2 points determine a line, we always take a third point just to make sure we haven't made a mistake anywhere. And now I can connect my dots. And there's the graph of the line y equals 3 halves x plus 2. That's the name of that line right there. And oh, I did something funny. This is the correct graph for this line. However, I made a little mistake. Remember when I subtracted 3x from both sides? This should have been a minus, but it's a positive. If it was a minus, then things would be reversed. My line would be going in exactly the opposite direction. So you can look in the book to see, this is the correct line for this equation. I just did my algebra wrong up there. Oops, sorry. I'll do the next one right, I promise. Well, that was right. I didn't say anything that should confuse you, except for maybe that. Let's do this one perfectly. Ready? X minus y equals 0. No, y minus x. I say I'm going to do it without a mistake, and then I literally cannot even say the word, but I wrote it correctly. All right, well, this looks weird. There aren't enough numbers, but if I add x to both sides, y equals positive. All right, well, I hardly need a chart. But I'll do it just to show I'm a team player. Y equals x. Okay, let's pick a number. Let's pick 0. I always like 0. If that's x and 0 equals 0, then that would be 0. Okay, let's pick 2. 2 equals 2. This is silly, isn't it? Minus 1? Minus 1 equals minus 1. Minus 1. Okay, let's graph it. This is a graph you can actually memorize. 0, 0, 2, 2, minus 1, minus 1. The graph for y equals x always goes through the origin and hits it divides both of these quadrants equally, right? Because we're always doing, 3 and 3, 4 and 4. It goes right down the middle of each of quadrants 1 and 3. So it's super easy to graph and you can memorize it. All right? Okay, you know what? I'm going to do that last example over because it's leaving a bad taste in my mouth, which is a really weird expression. But you know what I mean. I'm not happy with it. We had 3x plus 2y equals 4. We subtracted 3x. That's where my drama happened. 2y equals minus 3x plus 4. We divide everything by 2. And we get y equals minus 3 halves x plus 2. We make our chart. X, y, minus 3 halves x plus 2. That's what we do to change the x into the y. Ready? I'm still going to choose 0 as my first one. Minus 3 halves times 0 plus 2 is going to equal 2. So far, so good. I'm going to choose positive 2 for my next one because that denominator is still drama to me. Minus 3 halves times 2 over 1 plus 2. Okay, so the 2's cancel. So this is minus 3 plus 2 is minus 1. And then this time I'll choose minus 2. And this is minus 3 over 2 times minus 2 over 1. So these cancel, and the minus signs cancel. So this gives me positive 3 plus 2, so that's 5. This was hard to see. I know it's little and scribbly, hard to follow, but I'm just plugging in my different x values to this expression and then calculating my y's. Ready? I'm only going to write what I need. Oh, it's a little messy. 1, 2, 3, 4, 5. I need to go to minus 2. Minus 1. Okay, so now we graph our points. 0, 2. 0, 2. 2 and negative 1. 1, 2 and negative 1. And then negative 2 and 5. Negative 2. 1, 2, 3, 4, 5. And there we have the proper answer. And if you look, here's the page where I did it wrong. Look what happens when 0 and 2, those are the same. Positive 2 and 5, here it's negative 2 and 5. Negative 2 and negative 1, here it's positive 2 and negative 1. So the signs are just flipped around, but the values are right. So this is the right answer. Yay! I feel better now. I hope you do too. Lesson 56, enjoy your graphing.